Hi guys, welcome back. So here in this video I'm gonna go over projectile motion, which is basically the last topic of section 9.2. So what is a projectile motion? So projectile motion is an object launched into the air which moves under the influence of gravity. Okay, so if I assume this is an object and I launched it into the air and it is moving under the influence of gravity, so acceleration equals to 9.8 meters per second squared, and it is experiencing both the horizontal and vertical motion. So the component of it is broken down into two independent components. Okay, the horizontal component and the vertical component. Okay, so as the object is moving upwards, this is the vertical arrow, this is the velocity arrow. So the velocity of it is changing, right? So the velocity arrow points upward because the object is moving upwards, and at the very top the velocity is equals to 0. The velocity becomes 0, and it is then the object starts to move down, right? So this object is moving down, so that's why the velocity vectors points downwards, and then it eventually reaches the ground. Okay, and the horizontal, and if you see the horizontal component, the object is keep moving to the right, so it doesn't change. So the arrows just point to the right. Okay, so just like that. Why? Because the object is just moving to the right. The speed of it is constant. So as you know, like it is, I think, Newton's first law, right? An object in motion will remain in motion unless acted upon by an external force. Yeah, I think that was it for Newton's first law. If I'm not sure, just write in the comment that this is the Newton's second law. Oh, I mean first law. Okay, so yeah, so that's why the velocity, the speed is constant, because it's keep going in its same direction and without changing the speed. So that's why here the acceleration is equals to 0, because there is no change in speed, and no change in speed means the velocity is equals to velocity is constant, right? Okay, so in the horizontal component, we know the velocity is constant, but what about the vertical component? You see that the arrows shown you that the speed of it is continuously changing, right? I mean the velocity. Okay, so the velocity is continuously changing, and what happens when the velocity is changing? So what is the another name for a change in velocity? It's acceleration, right? So it's just because it's experiencing acceleration here, that's why in the vertical direction the velocity is not constant, and there is acceleration. And if you need explanation on why the velocity at the top is equals to 0, so for that, let's just launch any object that is near you, like any razor or anything, pencil or something, and let's just throw it into the air at an angle. Okay, and then let's see what happens. Okay, let's just throw it. 1, 2, 3. Okay, what did happen? Did it reach the ground? Right, it eventually reached the ground, right? Why? So when you throw it, it had its initial speed, right? So then and the speed of it was decreasing due to gravity, right? And then at the very top, the velocity is equals to 0. When the velocity was equals to 0, then the object starts to come down. Otherwise, the object would have never come down. Okay, so that's why the velocity at the maximum height is always 0. It is when the object is going to come down. Okay, so I hope you understand this. Okay, now let's move on. Alright, so let's just do the Cal 3 stuff. So the Cal 3 stuff is vector functions, right? So we are on vector functions. So we're going to be writing a vector function for this projectile motion. So, and I have explained what is vector function in my previous video. So if you want to check that out, I have posted the link in the description below. Okay, so let's move on. So a vector function is basically a vector whose components are functions of parameters. So we're going to be writing a function of parameter here. So here it's going to be in terms of x and y. So the first one is going to be x of t and then y of t. Okay, because there are two components, x and y, right? Independent, the vertical direction and the horizontal direction. And the parametric equations of it, it's going to be, so in the x direction, the horizontal direction, so these are the parametric equations, right? So here in the x of t, so what is x of t? So here x of t is the horizontal component that we're talking about, and here it is thrown with an initial speed, right? So initial speed is always given to you, so let's say that it's v0. So then since it's a constant speed, so it's just going to be, because it's x direction, so it's v0 cos of theta, the angle that is given to you, that is thrown at, let's say it's theta, so then cos theta t, and then y of t, in the vertical direction, it's going to be v0 sine theta t plus the initial height that it was thrown at, the height, okay, and then negative gt squared divided by 2. Which is the force of gravity. And so these are the formulas to find it. So these are the parametric equation and the vector equation. If you write it all together, it's going to be a vector equation, so which is going to be x of t plus y of t, right? So what it's going to be, v0 cos theta t I hat plus v0 sine theta t plus s0 negative gt squared divided by 2. Okay, so and then g hat, of course, because this is in the y direction. So if you're asked to find the vector function, you use this formula, and if you're asked to find parametric equation, so you write it in terms of components. Okay, so what are the vector functions in terms of this diagram? Okay, so let me use a different color. Okay, so the vector functions are going to be basically, you know, a vector function gives the position of a particle at any time. So okay, so the vector function that you're going to find, it's for example like that. So these are going to be vectors determining the position at any given time. So the vectors that are making this curve, so these are called the vector function. Okay, so these are the vectors that are made by this function, and then all these vectors together at any given of time will going to sketch this curve in 2D. Okay, and if you find the velocity function, this is the vector function. How are you going to find the velocity function? You're just going to take the derivative of this function. This will give you the velocity function. And if you want to find the acceleration, then what do? You take the double derivative of it, right? The double derivative of position gives you acceleration, or the single derivative of velocity gives you acceleration, right? Okay, so and then what does the velocity vector and acceleration represent? So the velocity vector, it's going to give the rate of change of the position vector and represents the instantaneous velocity of the projectile at any given time. And the acceleration gives the change of velocity vector at any given time. So if you guys want to note that, so I'm just gonna show you. Alright guys, so these are the notes. If you guys want to know what is a position vector, velocity vector, and acceleration vector, so you guys can take a screenshot of it, so you know, you guys remember what is a position and velocity and acceleration. Okay, so that was it for today's video, and don't worry, we're gonna do a problem in the next video, so everything is going to be clear. Until then, bye.